All right. So today we're going to review some things. Again, these are probably things that you remember from previous classes, but you've slept since then, and it's been a long summer, so you may not remember all of them, and that's okay. You'll get plenty of chance to practice these on homework assignments over the next couple of weeks. So the first two things we're going to talk about are perimeter and area. Perimeter of a shape is the total length of the boundary around the shape that encloses the interior region on a flat surface. Here are a couple of examples. For one like this, where you have a bunch of squares that have been put together, you just have to count all the way around the figure, right? Where you have individual side lengths, what do you do to those to get the perimeter? Anybody? Yeah. You just add those together, right? So sometimes people will say this then: the perimeter can be found. And if I'm writing something, you're writing it also, unless I tell you not to. Okay? Can be found by adding the lengths of all of the sides. So here, this perimeter is 20 units. Here, what's missing from this? Yeah, the units. Notice the problem gave us units, but my answer doesn't have units. To be fully correct, we need to have the units on this. So this is 23 centimeters. When they don't give you any units, typically we'll write units, although if you leave that off, I'm not going to make a big deal of it because they didn't tell you what kind of units. So if you just say the perimeter is 20, I'll be okay with that. All right, then area is a measure of the number of square units needed to cover a region on a flat surface. So here, the area is 11 because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares that it takes to cover that. You could measure the floor in this room, for example, by counting up how many of these floor tiles it takes. It takes this many floor tiles. Okay? Now, how do we do this? Well, if you've got a rectangle, you can find the area by just multiplying the base and the height. Typically, we call the base what's on bottom, although when you get to my geometry class in a couple of years, I'll be like, yeah, base doesn't have to be on bottom. Okay, base doesn't necessarily mean it's on bottom. Most of the time it is, but not always. And the height, which is the distance between these two. So here we can take 5 times 3 is 15 square meters. People sometimes say meters squared, which actually doesn't make any sense. It's best to say square meters because that lets you know, well, what is it we're doing? It takes 15 squares that are a meter on each side to cover this. So it's just a simple multiplication principle. And then the same is true if you have a parallelogram. A parallelogram has an area that's equal to the area of the rectangle with the same base and the height. If the base of a parallelogram is length b and the height is length h, then the area is b times h. Now, why should that be the same? Does anyone know why that's the same as it is for a rectangle? Yes, sir.
It's because a
Parallelogram?
and a rectangle have four sides.
That's true. They do both have four sides, but that doesn't work for all four-sided figures. Okay, so part right, yes. Yes?
Because it's just like a rectangle, except it's like the sides are like angled.
So why is it that that doesn't change the area, I guess would be my question then.
Because the sides have the same length as a rectangle.
Oh, but is this side?
Area, a rectangle with the same length.
Because this side is actually going to be longer than the height, isn't it? Okay, yeah.
If you like cut it off and add it to the other side, it's good.
Yeah, that's the way I think about it. If you were to cut this off and stick it onto the other side, what do you get? A rectangle. And this length is going to be equal to the original b, right? And this is going to be equal to the height. So you can make a rectangle out of a parallelogram just by cutting that triangle off and sticking it on the other side. And that's exactly the way I think about it. So let's do one of these. If we get a parallelogram that looks like this. Oh, by the way, when we're drawing figures and stuff, if you're a super neat freak and want to use one of these, it's a template drawer, you're welcome to just come up and grab one, and you can make really, nice, neat figures if you are into that. So the area here is going to be 16 times 3, which is 48 square inches. So just one formula so far. It's base times height. That works for rectangles and more generally for any parallelogram. All right, well, let's look at triangles. The area of a triangle is half the area of a parallelogram with the same base and height. If I'd made a copy of this and taped it on, and I'm going to do it in dotted, do you see how this triangle is exactly half of that whole parallelogram? And the area of the whole parallelogram would be base times height. So the area of a triangle is half of base times height. So I might have something that looks like this. So the area would be half base times height. I'm a big proponent of writing out the formula every time you use it so that you get it memorized quickly. So that'd be half of 15 times 6. Now you have a couple of options here. What's one thing you could do right now? Actually, there's several things you could do. Somebody raise your hand and tell me one thing that you could do. Yes, sir.
Do 15 times 6.
Okay, you could start with 15 times 6. And a lot of people start with that. And there's nothing wrong with that. Yes.
15 times 3.
Where'd you get 3 from?
I had the 6.5.
Yes, you could multiply. So what you did first then, although you didn't say it, was you multiplied the half and the 6. When you have a group of numbers being multiplied together, the order that you do them in is not important, is it? So if you're having to do this in your head or without a calculator, it may be faster to go, all right, half of 6 is 3, and 3 times 15, I can do that in my head. That's 45. Either way is fine. If you really want to get silly about it, what's another way that you could do it? Yes, ma'am. Sorry, you got to be a little louder.
Split both the 15 and the 6.
Are there 2 1/2s or just one? There's just one. So what I was thinking is the silly way to do it, or the hard way to do it, would be to take half of the 15, which would be 7.5, and then multiply that times 6. Still comes out to be 45, but that's a lot harder, isn't it? Numerically, at least. All right, and then the other one that we're going to look at is the area of a trapezoid. The area of the trapezoid, which looks something like this, you've got 2 different bases instead of just one base size. If we go back up here to the parallelogram, what's this length going to be? Same as the other one, right? But here I've got 2 different bases. So basically what we say is, all right, one of them's too big, one of them's too small, I'm going to average them together. So it's half of base 1 plus base 2 times the height. So let's do an example of this. Bless you.
Does that say 8 feet for the height?
Yes. So, anytime I use a formula, I tell everyone, this is the formula that I'm using, by writing down the formula. That's part of how you show your work. You say, this is the formula I'm using, and then I substitute into it. So that's half of 23 plus 11 times 8. What does order of operations say I should do first? Yes, ma'am.
Isn't that within multiplying?
Add them. Who are them?
23 plus 11.
Yeah, add the 23 and the 11 first. So that'd be half of 34 times 8. And when I multiply, I can multiply in any order I want. You can take half of the 34 and then multiply that times 8. Or you can take half of the 8 and multiply that times 34. Which one? And I'll just take a couple of volunteers. Actually, let's do a show of hands. How many think it'll be easier to take half of 34 and then multiply times 8? Okay. How many of you think it'd be easier to take half of 8 and then multiply that by 34? Okay. It's kind of split. Do whichever way you want to do, and then check your neighbor to see that they got the same answer that you got. So seriously, check your neighbor when you've got yours. hopefully, you got 136. Right? Is that right? Yes, sir.
Would it be cubic? Like in cubic?
I'm sorry?
Would it be in cubic? Like
No. This is area, so it's still square units because we multiplied feet times feet. So that's square feet. Okay, good question. Thank you for asking. I appreciate it. All right, so that's a little bit of area, a little bit of geometry. Let's go on to a little bit of statistics. So, two different things, the mean and the median. So, if you have a set of data, you might want to describe it with the approximate center of the data. One of the ways you can do that is to find the mean, which is also called the arithmetic average or just the average. And now I get to tell one of my favorite really bad jokes. Are you ready? I tell horrible jokes on purpose. Okay? Some people say I'm average. I say they're mean. Okay, some of you got why that was funny. Yes, and it was a horrible joke. All right, because mean and average are the same thing. To find the mean of a set of data, add the values of the data elements, those numbers, and then divide by the number of items of data. The mean is useful if it doesn't contain outliers. We'll talk a little bit about that in just a second. God bless you. Outliers are numbers that are much smaller or much larger than most of the other data in this set. So, suppose the following data set represents the number of home runs hit by the best 7 players on a Major League Baseball team during one season. It was 16, 26, 21, 9, 13, 15, and 9. Is that a particularly good team?
no.
If your best player didn't even hit 30 home runs in
30 is like a lot. Average is like 15 or above. Well, no, it's probably lower than that. Probably 12 is average. But if your best player only hit 26,
that may not be great. It's not horrible, and it's not out of the imagination, certainly. But typically, especially these days, you have players hitting lots of home runs. We just add those together, divide by 7. Notice the squiggly line here. What does that mean? Anyone?
Approximately?
Approximately. Yeah, this means approximately equal to. I would have just divided it and gone, okay, it was 15 and 4/7 instead of trying to make it into a decimal. Because the decimal for sevenths are always ugly. Right? Dividing by 7 is one of the ugliest things around when it doesn't go in exactly. So the typical player amongst the best 7 home run hitters on the team hits about 15 or 16 home runs each season, which is, it's not great.
it's average.
All right, so the median. While the mean is one of the useful terms for finding center, another one is the median. It also locates the approximate center of a set of data. Remember, when you find the median, you got to line your numbers up in order. It doesn't matter whether you go least to greatest or greatest to least. It's not important. Most people go least to greatest because they're more comfortable with that, because that's the way we count. And then you take the middle number. And if there are 2 that are tied for being in the middle, we take the mean of those 2. So, for example, again, this is the best 7 players on a Major League Baseball team, the number of home runs they hit in a season. The median here is 15. Once we put them in order, we've got 9, 9, 13, 15, 16, 21, and 26. Notice that there are 3 numbers below 15 and 3 numbers above 15. So the median is 15. Yes, sir.
Is there any correlation between the median and the mean?
Not sure exactly what you're asking by correlation. Are they always near each other? No. Let me give you an example. Okay? And what time does this class let? I'm not at all used to this new schedule. So this is 5th period, right?
Yeah.
So we're out at 12:06. We have plenty of time for this. All right. So we're going to use the people in this room. Okay? And here's what we're going to do. We're just going to real quick go up and down the rows. I want to know how old you are, just in years. You don't have to give me years and months or days or anything like that, just in years. All right? So go. Whoa, hang on. I got to be able to write them down. Next. Yep. Keep going.
Oh no, wait.
We're going up and down the rows. So
I'm so jealous.
let's start in the back. Bella. 12.
Yeah, we're averaging 12.
All right, hang on. So 12. And this is the most boring data set in the entire universe. 12. 12. Pardon? 12. All right, shh. Yeah. All right. 12. Great. But I said we were going to do the people. Shh. We're going to do the people in the room. I'm a people.
Oh, it's an outlier.
It's an outlier, folks.
That's a big
It is
difference.
12.
It should have been 22.
It's definitely an outlier, right? Way bigger than all the other numbers. Now, what is the median of this going to be? Without even counting, what is the median going to be? The median is going to be 12, right? Is the mean going to be 12? No.
Only like 15.
Well, let's find out. Let's see. There are 12, 13, 14 of you. 14 times 12. 28. Yeah, 168. Plus 62. That's 3. That's 130. Divided by 12, 13, 14, 15. 130 over 15. Both of those are evenly divisible by 5. 5.
Yeah,
It's 230. Derp. Thank you. Both of those are divisible by 5. That's 46 over 3, which is, that goes in once with 1 left over. 15 and a third. So by having an outlier, it skews the mean. It pulls the mean in the direction of the outlier. So there are times when you're going to want to know what the mean is, and there are times when you're going to want to know what is the median. Right? They're both the average, put that in quotes, the average, but they're different, aren't they? They're both, the center is a better way to say it. They're both a measure of the center, but, I mean, all by myself, I almost pulled it up to where you guys are ready to just start taking driver's ed. Right? Almost.
3 years.
Um,
We can get our
you can start taking driver's ed at 15.
Yeah, 15 years, bro.
So yeah, I pulled the average up over 3 years. Okay? All right. Any questions about that? Cool. I have a worksheet for you.